All right, and we are back for section 4 of our cybercrime course. This time we're going to be talking about networking. This is going to seem pretty complicated at first, but again, I'm going to try to explain this in really kind of simplistic terms. People who actually do this for a living might even describe them as overly simplistic. But again, the idea here isn't for you to understand these things at the deepest possible level. This is for you to just kind of get these ideas in your head and get a general idea of what these words mean and how these things work. And we can leave the details for a different future course, okay? So, when computers are talking to each other, that's one of the best things about modern computing, right? It's not only the ability to, have a computer to do things ourselves at home, it's to connect to other devices, right? Everything from multiplayer video gaming to online shopping to watching this lecture, right? And we have a worldwide network of computers that's been slowly building up since the late 1960s, called the internet, right? And the internet is just that giant worldwide network of billions of different devices all connected to do, a nigh on infinite amount of jobs, whether it be video gaming or web browsing or surfing YouTube or taking online courses or, downloading data from somebody else, sharing pictures of your grandkids. Dang near anything can be done over this giant global network. There is also the concept of an intranet. And an intranet is a much smaller network of computers, usually in one physical location. So like here at my home, I have an intranet. I've got my desktop, my wife's desktop, my laptop, my cell phone, the television. All these things are connected to one smaller network just inside my home. And if my connection to the internet goes out, I can still have those devices talk back and forth to each other on that smaller household intranet, even if I can't access the internet for some reason. Okay? Now, when I take data from another source and bring it down to my computer, that's called a download. When I take information from my computer and I send it out to somebody else, that's called an upload. And one of the things that kind of most people don't pay attention to, don't realize, is that when you're paying for a certain speed of internet, the ISP nearly always advertises those speeds of the download, not the upload. You're usually far slower to upload data than you are to download data because, as a normal end user, the vast majority of what you do is downloading, right? If I'm watching Netflix, that's 99.9% download. The only upload is me saying to Netflix, hey, send me this movie or send me this TV show. And then all the other ones and zeros is going from them to me, and I am thus downloading them. So we don't necessarily need anywhere near the same amount of upload speed as we do download speed. But if I want to connect to the internet, I need to have an ISP, or an internet service provider, okay? And in my case, personally, I have Xfinity cable through the old school cable television network. They have brought broadband internet to my home, and that's the company I use to connect this desktop computer that I'm recording this on out to the global internet. There are hundreds, probably even thousands of different internet service providers the world over. But usually these internet service providers aren't doing the bulk of the data transmission. It's only connecting you from your doorstep to what's called the internet backbone. And these are the really big, really heavy duty pipes and connections city to city, state to state, country to country, that perform the vast majority of the data transmission work. And here in the United States, this is essentially a monopoly, a 5-company monopoly. I can't remember all 5 of them, but it's, Quest, what used to be Sprint, a few other companies run the entirety of that backbone. And no matter what ISP you're using, it's essentially just them connecting you from your house to that backbone. So with a little analogy, the backbone is kind of the interstate highway system. Lots and lots of cars at really high speed. The ISP is the kind of smaller residential roads that connect your driveway to those interstate highways. So if I'm going to drive from here to, Washington, D.C., I'm going to use those residential roads to connect me to the interstate, then use the interstate most of the way there, then use a few of the smaller roads again to actually get to my final destination. Same thing with ISPs. I'm going to use my ISP to get from my house to the backbone. The vast majority of the trip is going to be along that internet backbone. And then another ISP for whoever I'm trying to discuss it with will send it those last few miles, last few inches into that other person's device, and I can connect and do video gaming or web browsing or whatever. Now, when I'm talking over the internet, there are lots of different languages I can use, right? Some of the more common ones are things like TCP/IP, which is used for web browsing. There's UDP, which is used for large data dumps like YouTube videos and such. I believe still uses UDP. And they're all slightly different languages, which slightly different methods of sending and receiving data. But again, the exact kind of nitpicky differences between these different languages or different protocols, as they're referred to, is really kind of beyond the scope of this course. Just know that there are slightly different ways to communicate over the internet, slightly different, again, languages. It's like English versus French versus Spanish versus German. But in this case, it's slightly different ways of sending packets back and forth from one person to the next. Now, the reason the internet became such a huge phenomenon, the reason it's so adaptable and so interesting and such a really amazing interconnected network is because it doesn't use a constant connection between kind of person A and person B. It divides up every message that gets sent over the internet into little itty bitty chunks called packets. And each one of those packets gets sent out, routed to the target, and then reassembled by the target into the original message, right? So this video that you're watching right now had to be cut down into millions of teeny tiny little chunks of data. Each one of those chunks took its own path to you and your computer, and then your computer reassembled them and displayed this video for you. This is a process called routing, right? So as you can see here in this very simplistic diagram, this person is sending 3 packets of data to this person. Now, the first packet comes out, goes along the ISP, and it says, oh, what's the fastest route from me to person B? Oh, it's this way. Now this person says, what's the fastest route from me to person B? Oh, it's this. And so you can see this first packet takes this green path from server to server to server, device to device to device, until it ends up at the target. But then the second packet comes along and it doesn't take the same path. It has decided that the fastest route is now this route among this completely different set of servers and computers along the global internet, and eventually ends up at person B. Now the third packet comes out and takes a new route from person A to person B. But they all eventually get there to person B. Their computer reassembles those packets into the original message, and they get to read that email or watch that video or play that online video game or whatever once those packets are all reassembled at their destination. Now, how does each node upon this network know where it's headed? Well, each packet, each little chunk of information has a header on it. And the header is essentially, think of it like the outside of an envelope for, like sending old school snail mail, like through the post office. And it's got kind of it's got its stamp on it saying it's legit. And importantly, it's got the address of where it's going, right? So each one of these nodes doesn't have to actually read all of the data in the packet. All it really needs is the header information for where is this packet going? Where is it supposed to go? Right? And then it can send it on its way toward that destination. And remember, computers don't like to use English. They don't like to use addresses the same way we do. So whereas we might have an address of 1234 Main Street, computers want to use binary. So their version of an address is called an IP address. And each device on the internet has to have a unique IP address. And the old school system that is still semi in use is to have 4 bits of information, each separated by a dot. And remember, each byte of information can be anywhere from 0 to 255. So that's 256 different options, right? So an IP address might look like 192.168.5.17, right? That would be a valid IP address. And each one of those has to be unique to be able to connect to the global internet, because each packet has to know which specific device it's heading to. They're currently upgrading the IP system, and there's going to be a new system that has far more options, because 256 to the 4th power is only a few billion, and we have that many devices connected to the internet already. So they're having to use different tricks to kind of cut down on the number of IP addresses given out. So for instance, my home only has one IP address, and then my home router that I use to connect to the internet has to every packet that comes in, it has to figure out which of the devices connected to my home intranet to send those packets to. Now, some of the things we need to talk about in networking that are going to come up later in this course are VPN and DNS. VPNs are virtual private networks. Okay, so in essence, this is like a middleman for internet communications. Now, in this old school, if I just connect to, say, a web service, that web service is going to be able to see exactly where the packets I sent them came from. They're going to be able to see my IP address. Every packet I send them not only has their IP address on it so it can get from me to them, but it's going to have my IP address on it, so they're going to know how to reply, right? But what if I'm a bad guy and I don't want them to know who I am? I don't want them to have my IP address so they know exactly who it was who connected to their system and sent them a virus or hacked through their password system or whatever. Well, if I use a VPN, those packets are going to go from me to the VPN service to the target. And then the target isn't going to be able to see where those packets came from. They're only going to be able to see that it came from this VPN service, right? So now if I'm an investigator and I have a victim of a crime, I'm going to look at those packets that came in, find the IP address of their source. That's going to lead me to the VPN, and then the VPN is probably going to tell the FBI, hey, we're not going to tell you where those packets came from, either because we didn't record them at all, or because we're hosted in a foreign country and you have no power here, or lots of other reasons. And that's going to help prevent law enforcement from tracking down exactly who I was as the bad guy that sent all that computer virus to the victim. And you can of course chain these. You can go from me to a VPN, to another VPN, to another VPN, to another VPN, to the target, right? And then any one of those VPNs will probably be able to stop law enforcement from tracking it back to me, the original sender of those packets. Now, DNS is a little more simple and complicated at the same time. So I just said that every device has this IP address, and it's, number. But we as humans, we're really bad at memorizing those things. So what humans are good at, computers are bad at, and what computers are good at, humans are bad at, which is one of the reasons why computers are so darn useful. But one of the things that computers are good at that we're not good at is remembering these numbers, like number. So we need something else for humans to remember in order to know what target we want to send packets to. So for the World Wide Web, that looks like a web address, right? www.nfl.com, www.paypal.com. Those are easy for us to remember, right? But a computer can't really do anything with that. It needs a translator service. So DNS, or the domain name system, is there. So if I go into a web browser right now, and I open up a web browser, and I type in paypal.com, the first thing my computer is going to do is say, oh my God, I don't know what paypal.com means. And it's going to contact DNS and say, hey, DNS, my user wants to go to paypal.com. What's the IP address associated with that name? And the DNS will reply to my computer and say, oh yeah, paypal.com. The IP address associated with that is 5.13.212.15 or whatever, right? Picking some random numbers. And then my computer will say, oh, thank you, that's much better. And now it'll know who to send those packets to in order to communicate with that website and display that information for me through my web browser. Now, I know that was a lot of information, a lot of really complex stuff, but we will be back in just a moment.